number 4, we want to talk about some of the observations that you should have seen.
Ready?
You should have seen that the paper punches move in the direction of the airflow from the straw. The punches lie on the water's surface and that they are moving along with the water. Friction with the moving air causes the water to move. So now we're looking at the analysis questions, and for number 1, it's asking you to determine why were the paper punches you placed on the surface of the water in your pan an important part of your model.
The paper punches allowed me to observe how the water moved when I blew across its surface.
For question number 2, it asks, how did the model you constructed in part A represent the interaction between the atmosphere and the hydrosphere?
My breath blowing out of the straw represented how wind interacts with the surface of the ocean, which was represented by the surface of the water in my bin.
Number 3, use a cause and effect relationship to explain how surface currents form. Use evidence from your model of surface currents to support your explanation.
Surface currents form as wind blows over the ocean's surface and pushes the water along. The paper punches in the water were not moving until I blew across the surface of the water through the straw. Then the paper punches moved along, pushed by my breath, which represented the wind.
In part B, some observations you should have made were that the ice water, which was colored blue, sinks below the room temperature water. The greater the temperature difference between the two parcels of water, the more likely a current will form. This is a convection current.
Notice when we're dropping in the blue water, this is actually colder than the other water, and it sinks almost immediately to the bottom.
In the model you constructed in part B, what variable affected the movement of the blue water once it came in contact with the warm water in the plastic?
The variable is temperature. I saw the cooled blue water sink beneath the warm water.
Question 5. Matter sinks when it is denser than the material it is placed in. Matter floats when it is less dense than the material it is placed in. Use this information about sinking and floating to construct an explanation for the observations you made in part B.
The cold blue water sank in the warm water in the plastic cup or bin because it was denser than the warm water.
Some observations you should have made in part C were that the salt water sinks below the tap, the unsalted water. We used room temperature water in both the plastic pan and in the foam cup, so that temperature was not a variable. Part C, question 6. What variable affected the movement of water in the model you constructed in part C? Describe what you observed.
The variable is salinity, or the salt content of the water. Ours was 5%. I saw the red salty water sink beneath the water in the bin, which had no salt added to it.
Question 7. Explain what you observed in part C in terms of density.
The salty red water sank because it was denser than the tap or unsalted water surrounding it. It has more particles dissolved in it.
All right, and now for your answers for the conclusion questions. Number 8. Describe what you think the temperature and composition of the water in a deep current would be like.
I would say the water in a deep current would be very cold and very salty because both of them seem to sink in our experiments.
Number 9. Use a cause and effect relationship to explain how deep currents form. Use evidence from your models of deep currents to support your explanation.
Deep currents start to form where the surface water gets very cold and very salty. The cold, salty water sinks deep below the surface, and because more cold, salty water follows it, it gets pushed along near the seafloor, forming the current. In my temperature model, I saw the cold water sink to the bottom of the cup or the bin of warm water. In the salinity model, part C, I saw the very salty water sink to the bottom of the bin of tap water.
Last question, number 10. Where on Earth do you think deep currents might form? How can they drive global currents? Use scientific reasoning to explain your answer.
Deep currents may start to form near the poles because that's where the coldest water is on Earth. The water could be saltier there too because there's a lot of ice near the poles, and ice is not salty. That means that the salt in the ocean water must stay in the water that does not freeze. Variations in density due to variations in temperature and salinity drive a global pattern of interconnected ocean currents.
Thanks for watching. Hope you learned something.
Woo!